So as far as Hawks goes, if you haven't created an account before, one of the things you want to do is go to that learn.hawkslearning.com. Let me write that on the board if you haven't done this before. Now you can buy an access code at the bookstore. However, if you buy it through Hawks Learning directly, it's a little bit cheaper. It's a few bucks cheaper if you buy it through Hawks directly. If you haven't done it before, you would go to that learn.hawkslearning.com. This page pops up. You click create an account, and you get these options. You get the one on the left is I have an access code. That's if you bought the access code at the bookstore and they gave you a physical license code. That's where you would click there. If you haven't gone to the bookstore and purchased it and want to purchase it online through Hawks, you go to I want to purchase access and click on the right one. If you want to wait and see if you really like me or not before you decide to drop the class later. Sorry, trying to make a bad joke, it's fine. I make bad jokes all semester, you'll get used to it. It's okay if you point and laugh at me too, it's fine. Okay. Or if you want to wait, or if you don't necessarily have the money right now and need to wait to buy it, you can go to request temporary access at the bottom. This will give you access for 21 days. But after that 21 days, they just cut you off. And then you will have to purchase it or you won't be able to do your homework. And also Hawks is basically your textbook too, because we don't have a textbook for the course. So once you do that, it leads you through what you need to do. So I do the select temporary access. You put in your name. You'll select your school. So you know where, hopefully you all know where you go to school. But after you do this, you go through and you'll also pick your instructor's name so you can find me. And as well as you need to pick the section. There should only be one section that pops up that's under me, because this is the only class I'm teaching this semester that uses Hawks. Bless you. Okay. Also, make sure if you have not purchased the software yet, make sure you purchase the pre-calculus software. That's what we use for this class. Okay. Luckily, there's not a trig software in Hawks. There is a college algebra one, so if you are in college algebra, you need to make sure you purchase pre-calculus and not the college algebra. Okay. Because again, once you buy it and use the license code and log in, it's burned and you can't get a refund, which sucks, but that's what happens. So anyway, if you have any issues at all getting into Hawks, give me a holler. But you need to get it at the very least, get in there and get your temporary access if you can't purchase it right now, because that homework's due on Sunday. Yes.
If you already got a login, can you still get a temporary access?
If you already have a login, I'll show you how you transfer yourself here in just a second. Yeah. Okay. All right. So, and again, if you have any issues, come see me. I can get you logged in, and if something's really, really screwed up, we'll call Hawks. But if you have any issues, just holler at me. I'm more than happy to help. All right. So let me show you how to transfer yourself if you already have an account. Oops. And that's what I thought I mistyped it. Oops. Now the caps lock's on. There we go. All right. I have lots of different things in my dashboard that pops up, but my guess is you may have one or two depending on if you took intermediate algebra or not. So scroll down here. So you should see, if you already have the software from college algebra, you should see the pre-calculus one there. And it still should show stuff from last semester. Okay? Unless you've already transferred yourself, and then good job. You don't have to listen to me. All right. But anyway, if you notice back up here at the top, there's a transfer button. This should be up in the upper right-hand corner for you. If you click on that, and assuming the Wi-Fi works, you should be able to get to your pre-calculus access code. You don't have to touch anything with that. We just hit transfer here. And then, again, you should be able to go through this. What school, what's the product, who's the instructor, The product, you shouldn't be able to change the product because it should just say pre-calculus because you're just trying to transfer yourself. Who's the instructor? Just find me. And then, as I said, it should only be the one section that's under me. Okay, this should be the only thing that's visible for you. Okay. Yes?
Well, if we were trying to transfer, why is it showing? Like, why would it only show one? Like, why would it show the one that we're trying to get into?
That would be the one. You have to switch it to me first, and then it will just be the one that you're trying to get into. After you switch it to me, this literally should be the only thing that you are able to select. Because again, I'm the only one. This is the only class I'm teaching that uses hogs, so there shouldn't even be another option. So once you find me, it shouldn't be an issue. I think I can probably switch over to Dr. Stuckey's classes. I can select any of those professors. So when you get to the pre-calculus and it says select your instructor, you should be able to see all of those people. You might make sure you select me and not the other Dr. Stickles. If you select the other Dr. Stickles, you're going to be confused. All right. So then you can transfer yourself. Again, if you've got issues with that, let me know and we can get it fixed. Questions on that at all? I know some of you were already in Hawks. I checked yesterday. There was a few of you already in there. It was great. All right. So let's talk a little bit about, just to show you what the interface looks like in case you haven't seen it before. I know many of you have, so not too worried about that part, but just to show you. You'll notice that under the pre-calculus, it has when things are due within a week or due later. So notice that it already says your first assignment is due within a week. When you click on that, it takes you to that particular lesson. You've got the Learn mode, which is essentially your textbook. So if you want to read through examples, read through some prose, that's in the Learn mode. Your Practice mode is to give you practice problems. If you're struggling with something, you can go through and get step-by-step tutoring just to show you what a particular problem looks like. So in this case, let me see if I can zoom in a little bit so it's not so small. So in a particular problem, it just comes up and it tells you to enter your answer here. This one's not necessarily a good example of what we need to do, but sometimes it'll require special characters, especially in here. Some of our answers will be in multiples of pi, so you'll need to make sure you can enter pi in. So over here off to the right, which since I zoomed in so far, you can't really see it, you may need to pull up the special keyboard, and you may have done this in other classes as well. Pi is down here at the bottom. And then also notice, of course, we're doing trig, so we'll be doing things with trig functions. So at the bottom here, you've got the different trig functions that you can enter. Yeah. So you'll need to make sure that you use that keypad to get these other things in there. Okay. So honestly, entering the answers probably one of the bigger things to get used to in here, because you'll have to open up that keyboard and select the different things. So, all right. Anyway, if you've got any issues with Hawks at all, please come see me. We can get those things worked out. All right, so let's talk about some stuff that we're going to learn in this particular section. So, get over here to my... Yes?
The way you teach, is it really kind of like Hawks? Because coming from college algebra, from Hawks, that Hawks was kind of confusing.
Mm-hmm.
But like going over everything, it was a lot better. Like, maybe if we were to get like work, like when we got a worksheet, I feel like the class thought it was a lot better because Hawks was just really confusing. In the way
I've got lots of worksheets. I got lots of worksheets for this class. Yep, I promise. All right. As a matter of fact, I've got one here in a little bit. All right. So, yep, you're welcome. All right. So, that was weird. There we go. All right. So, when we're talking about trigonometry stuff, one of the first things that we need to talk about are angles and some special triangles that we'll be using as we go along. Also, we're going to have some special things with circles as well. So when we talk about trigonometry, we want to have a way to assign, basically what we're talking about is talking about angles and ways to assign numbers to angles so that the size of the triangle doesn't matter, is really what we're headed towards. So to get to that point, we need to talk about angles, all right? So when we have an angle, of course, we remember stuff from geometry. When we have an angle, we know we have a vertex and we have two rays that come out of the vertex. That's our geometric definition of angle, right? Okay? The two rays have a common initial point, right? So when we're talking about the measure of an angle, actually for this one, this actually defines two different angles, if you will. We've got one here, right? We've also got one here. There's actually two angles there, right?
Yeah.
One's just really big, okay? They look the same. The two sides are the same. But these measures, if you're talking about measuring these things, would obviously be different, right? Yeah. Okay. All right. So what we want to do is to try to standardize these things, relate these things one to another. So when we talk about these particular angles, I could draw the angle however I want, and this one could be the same angle if I wanted to, right? I could take this angle and I could spin it wherever I wanted to or slide it wherever I wanted to. As long as I didn't open it or close it more, it's the exact same angle, right? It would have the exact same measures. So when we're standardizing these things, the first thing that we want to do is put it on an XY axis. Okay? So what we're doing here is we're going to refer to standard position of an angle. Okay? So when we do the standard position of an angle, the first thing you do is you put one of the rays, let me change the color so you can actually see it. One of the rays here on the positive x-axis. And we refer to this as the initial side of the angle. Okay. So this is what we mean by putting an angle in standard position. One of the sides, which we refer to as the initial side, goes on the positive x-axis. Okay? Let's just write that down. So the initial side goes on the positive x-axis. All right? So then your other side, and I'll keep it red. Why not? Your other side then lands where it lands, right? In this case, I would think about taking whatever this angle is and rotating it around so maybe this side hits right here. Okay? That second side lands where it lands. We refer to that as the terminal side. And so that's what we have for standard position. But the important part is that one of the sides, your vertex goes at the origin, and the side goes along the positive x-axis. Okay? Now again, like we had before, there's really a couple of ways, and actually there's infinitely many ways, to talk about the measure of this particular angle. The two kind of obvious ones are this one that goes this way, right? Going from the initial side up. Or the other way would be going from the initial side and down and around, right? It's a couple of different ways we could measure. Okay? So when we talk about the difference in these two, we use positive or negative for the angle. Yes?
So what's that word?
That's positive. Sorry, yeah, my handwriting sucks. So if you got questions, please ask. My handwriting is awful. All right. So when we talk about which way did we go, we always start measuring from the initial side. And we either go up to the terminal or down and around to the terminal. Okay? But it always starts from the initial side when we measure. Okay? So again, just to write that down, measuring an angle in standard position always starts at the initial side. Always. You always start at the initial side. And then again, you can go up or down. So if you start going up and rotating counterclockwise, so up and around to the left, that's the positive leg. Okay? So counterclockwise. What's interesting is this word's getting more and more out of, I'll say out of vogue or out of fashion. How many clocks do you see with hands on them anymore? Just not that many, right? Most clocks are digital, right? Mm-hmm. So saying what I mean by counterclockwise, some people, I don't know what you mean, because you may not have actually seen an analog clock. But so this is up, whoops, up and to the left, right? Going up and around to the left. This is positive measure. So then clockwise, or down and to the right, down and to the left, is negative measure. And again, if you have any issues seeing anything, holler. All right, so we need to talk about a unit of measure, and there's two big units of measure that we're going to use. And one of them is going to be exceptionally important in calculus, which will be the one that we focus on more as we go through the semester. So the first one that you're probably more familiar with is actually degree measure. And the other one's radians, yep. So the degree measure, basically what we talk about is we divide a circle into 360 equal parts. And each part is 1 degree. And we use a little superscripted 0 for the degree. That one's one that you're probably familiar with, right? So some of the ones that are important for our purposes. So we just said that if we go all the way around like this. So this would be, this is an angle, by the way. The initial side and the terminal side are laid on top of each other. All the way around, and I went counterclockwise. So what would be the measure of that particular angle?
Positive.
It'd be positive, and what would the number be? If I go all the way around, 360, right? Right? It's not 4 radians. Yeah, we'll talk about it in a second. Okay, or we'll do it. What if I went this way and I stopped halfway? It'd be negative 180 degrees, right? Does that make sense? Okay. What if you, just to do one more here, what if I went all the way around backwards and then went all the way to here? So first, is it positive or is it negative? It's negative, right? It's certainly negative, isn't it? And then from here all the way to here, if I stopped here, that'd be negative 360, right? How much more did we go? We have the negative 90, right? So all together it'd be negative 450. Good. Yep, I agree. That okay? Yeah. All right. Notice that we could have measured this a couple of other ways, right? I could have also said, what's this measure? That's negative 90, right? Negative because we went clockwise, and then 90 because I just stopped, didn't I? Now, from an angle standpoint, I really can't tell the difference, correct? Because they still have the same initial and same terminal side. It's just, did it spin all the way around once or not, right? Or if I measured it this way, what would you tell me?
Positive 200.
Yeah, it'd be positive 270, right? Positive because we went counterclockwise and we went around 3/4 of the way. Right? We okay with that? Notice that all of these have the exact same measure. We refer to these, we give these a special name. We call this -450, this -90, this 270 are examples that we refer to as coterminal angles.
You don't have to line the circle.
The unit circle? I don't use the unit circle. Those are examples of what we refer to as coterminal angles. And what we mean is that they all, remember, every single angle in standard position has to have the same initial side, right? Because the initial side is on the positive x-axis. So coterminal angle means that the terminal sides are the same. That the terminal side lands on the same spot. Basically, think about a spinner. You just flick the spinner, it goes around and around and around, right? If it, say it lands on 2, does it matter if it lands on 2 if it went around 3 times or 7 times? No, because it still land on 2, right? For spinner purposes, right? If you're spinning something and you want to know where it lands, if it lands on 2, it doesn't matter if it landed on 2, if it went around 3 times or went around 7 times, or if you decided to flick it this way instead of that way, right? That's the idea of coterminal. It's just where did the spinner end up? Yes.
So you're saying coterminal is the initial side?
Well, the initial side is the same for every single angle, doesn't matter, because we force the initial side to be here, right? No matter what, the initial side is always on that positive x-axis. So it's where that terminal side lands. Yeah, that's why I was trying to use the spinner analogy, because it spins around. Yeah. Yep. All right, cool. Okay, so that's degree measure. The other measure that we use is what's referred to as radian measure, and it's measured by length of the circle rather than opening of an angle. So, why do you keep doing that? Stop it. There we go. All right. So, to talk about radian measure, if we talk about a circle, oops, and we have an angle, so change my color again here. We've got an angle here in standard position. It cuts off a piece of the circle, right? Okay. So the radian measure of the angle oops, it's a ratio actually. If let's say I'll say it's S over R, where S is the arc length and R is the radius. Okay. So what I mean here is this piece here that we cut off, it's in geometry words it says it's subtended. So I'm not going to use that word ever again. That length is that S is the length of that arc. That's what I mean by S. R is the radius of the circle, so it would be this distance from here to here would be your R. Okay. So you do the ratio of that thing. And the reason why we do ratio, you've done similar triangles back in geometry, way back when. I don't want this to depend on the size of the circle. If I take another circle and drew a bigger circle, I would want that ratio to be the same. So if I took another circle and drew it this way, if I take that arc length over that new radius, it's the same ratio. They're similar, like triangles, right? It doesn't change. Okay, that's why we do it as a ratio rather than just as the specific arc length. Okay. All right? Okay, so to talk now, honestly, you don't really need to remember the definition if you understand how it works. Okay, so let's talk about how it works. So let's say, and let's think about that first example where I just drew this all the way around. Say I drew this all the way around like this. You told me in degrees that was what? 360, right? What if I think of this now? That's a really bad circle. But what if I think about this as a circle? And what if I think about this as the radius here is just 1? Can I figure out how far around I went? What is how far around you went? What's the name of that? The circumference, right? And what is circumference equal to? Okay, yeah, so it's pi times the diameter, which is also 2 times the diameter is 2 times the radius, so it's 2 pi r, right? What did I tell you the r is in this particular case? 1, right? So the circumference for this one, or our arc length, would be 2 pi, right? All the way around would be 2 pi. We agree? Okay. So this means that your 360, we also said that was 360 degrees, right? So that 360 degrees must be 2 pi radians. Remember I said that the radians was your arc length divided by the radius? Arc length was 2 pi, the radius is 1, so you just get 2 pi, right? So this basically is the big thing to remember of how you can relate your radians to your arc length. I'm sorry, your radius to your degrees. I said the wrong word. I do that quite a bit, actually. Your radius to your degrees. All the way around is 360 degrees. All the way around is 2 pi radians. And so that gives you an idea of how to convert one to the other. So, for example, if I wanted 180 degrees, it'd be 1 pi. Good. Good. Because it's just half, right? We agree? Okay.
That's why I say I thought we took those.
Yeah, yep. Yeah, I was just doing it in terms of the radians is all. Yep. Yeah. So what if I wanted, say, 45 degrees?
5/4.
It'd be 5/4. Good. So notice why. If I divide 180 by 4, I get 45. So divide pi by 4, I get 45. This is the big one to remember to help you convert back and forth, by the way. Right? So as another example, so say you wanted to convert negative 150 degrees to radians. Well, you would take your negative 150 degrees. I want to convert it to radians, right? So I would need to multiply by, well, let's think about over here. Think about units, if you will. If you're a chemistry person, you'd like to deal with units, or maybe you don't like to deal with units, but you have to, okay? But if you're a chemistry person, you deal with units all the time, right? I want to divide out the degrees and multiply in the radians, right? Doing that dimensional analysis kind of thing, right? Sounds like a chemistry thing, doesn't it? Okay. I haven't had chemistry since high school, but I can still talk about the dimensional analysis stuff. So if I want to divide out by the degrees and multiply in the radians, using this equation, I would have to put pi on top and 180 on bottom, right? That would cancel out the degrees and bring in radians, right? So you would get 150, that'll be negative still, 150 over 180 times pi. And then I could reduce that down to 5/6 pi. Divide top and bottom by 30. That one lands on the unit circle too. You see where I got this though?
Yeah, I never thought of it like that.
Yeah. Right, so that's how we can convert, and basically you can do it as dimensional analysis kind of idea, right? Or if you wanted to convert, say I wanted to do So I wanted to do 9 pi over 3 to degrees. Now, even though we call it radian measure, radian is unitless. And there are no units attached to a radian. We usually write radians if we want to make sure that we're specifying we're doing radian measure. But notice we divided it as arc length, a length, divided by radius, which is also a length. So the units cancel. Right? There's no unit in a radian. So if you, pardon me, if you see an angle written with no units, you assume it's radians. And as we go through the semester, we're going to do more and more things in radians and less things in degrees. Okay? Because calculus, all done in degrees. You get to calculus, it's all, excuse me, I just said that backwards. In calculus, it's all radians, no degrees. Okay? So we're going to wean ourselves off of degrees and start using more radians more and more. Okay? But if you see an angle with no unit, no degree symbol, assume it's radians. It has to have a degree symbol to be degrees. Okay? All right. So same idea here. This is 9 pi over 3. I'm going to write radians to think about that dimensional analysis idea again, right? To get rid of the radians, I would have to divide out radians, right? And introduce degrees, correct? So what needs to go on top? Now if I do 360, what would go on bottom? 2 pi, okay. Usually I think about it as 180 and pi, but you're right. The 360 and the 2 pi is perfectly fine. It works the same, right? Okay. If you do it 360 and 2 pi, I'm going to be exceptionally happy.
Could you just substitute the pi for 180 degrees?
That's essentially what I'm doing, yeah. Yeah, you're right. I'm just trying to keep that same idea that we did in the previous thing. But yeah, you're exactly right. I could take out the pi and put in the 180. Yep. So we would get these cancel, right? The pi's go away. 3 goes into 180 60 times, and 60 times 9 is 540. Does that make sense? I don't know why I wrote 9 pi over 3. That would have been reduced to 3 pi anyway. So, but anyway, the idea was the same. This okay?
Yeah.
All right. So that's converting angles. Let me talk a little bit about a couple of special triangles. I'm not going to get to the worksheet today, so that's the first thing that we'll do on Friday before we talk about new stuff. But let me talk about a couple of special triangles, because these triangles pop up a lot for us to be able to do trig functions later. So the first special triangle we refer to as a 45, 45, 90 triangle. Usually we'll draw it this way, but it doesn't really matter how we draw it. All right. So what we mean by 45, 45, 90 triangle, of course the 90 is your right angle, right? Okay, so we would have, even though I've got it rotated funky, I have these two angles are the same, right? So what would that mean about these two sides? They have to be the same. It's an isosceles triangle, right? If the two angles, the base angles are the same, then the sides are the same, right? We also know from a right, what's the most famous theorem you know about right triangles? Pythagorean theorem. Cool, good. I like that knee-jerk reflex on that. That's cool. Good. So I could also figure out what the lengths of those sides have to be using Pythagorean theorem in terms of each other. So usually we think about it as 1 and 1, because those would be the same. If each of those was 1, then this one has to be square root of 2, if you do Pythagorean theorem to find it. Okay. So this is one special triangle that will pop up that we'll want to use. But the big thing to remember, especially for the hawk somewhere that's over this section, is that these two sides are the same. Okay. The length of those sides later on is going to be more important for figuring out the trig functions for angles. The other special one is a 30, 60, 90 triangle. Again, the 90 is referring to the right angle. I'll put the 30 up at the top and the 60 on the bottom. Doesn't really matter where they are. The idea is the length of the sides. Okay. Again, if you've got Pythagorean theorem, you can figure out some things. if this side here has length 1, then so the side opposite the 30-degree angle, if that's length 1, then the hypotenuse has length 2. And then this side that's opposite the 60-degree angle is square root of 3. These lengths, like I said, these lengths will be important when we start doing the trig functions of these angles later on. This is not too hard to see why it has to be true. And the idea is just to show you real quick where this comes from. Because I hate writing things down and not show you where things come from. Say you had an equilateral triangle. Oh, you had 60, 60, and 60. And I made this side, say, length 2, which would mean this side was also length 2, right? What happens if I take this and drop it perpendicular straight down? What's it going to do? Well, it's going to split this side in half, isn't it? And make that a 1. And then you can use the Pythagorean, and it splits the angle at the top in half, too. It makes it a 30. And then you can get the length of that height by the Pythagorean theorem. That's where that 30, 60, 90 triangle business comes from. You don't have to remember reproducing that. I'm not going to ever expect you to reproduce it, but I just wanted to show you where it came from. Okay. All right, so we'll do the arc length and area and speed stuff next time, as well as to get into section 6.2. The big thing you should do before Friday is make sure that you can get into Hawks, either get your purchased access and get in there. At the very least, if you can't buy it now, get your temporary access. Okay? All right. Have a good one. We'll see you Friday.